The problem that we are going to discuss today is from the recent July Long challenge, and the problem name is Chef versus Bharat. The difficulty level of this problem is easy and its prerequisites are modular exponentiation and prefix sums. Let us try to understand the problem statement. So, Chef and his friend Bharat have decided to play the game the CHEFORA spell. So, in the game, a positive integer n is considered a CHEFORA if the number of digits d is odd and it satisfies the equation n is equal to summation I is equal to 0 to d minus 1 ni into 10 to the power I, where ni is the ith digit of n from the left in zero based indexing. So let us just quickly see an example. So let us take a number 1025. So let us see what does this equation give us the output. So considering digits from the left, so we have first 1 into 10 raised to 0 plus 0 into 10 raised to 1 plus 2 into 10 raised to 2 plus 5 into 10 raised to 3. So this is nothing but 5, 2, 0, 1. So if you see, the equation gives us the exact opposite number to our original number, right? Now let us read further in the problem statement. So let AI denote the ith smallest CHEFORA number. Okay. Now they will ask each other Q questions where each question contains two integers L, R. Now the opponent has to answer with the multiplication of AL to the power AI. So just let me write some multiplication from I is equal to L plus 1 to R of AL to the power AI modulo 10 to the power 9 plus 7. So we have to output the value of this equation or this expression. So Bharat has answered all questions right, and now it is Chef's turn. But since Chef fears that he could get some questions wrong, we have to come to his rescue. So now we have read the problem statement and seen a short example. Let us quickly proceed to the solution approach. To start off with the solution approach, first let us actually see what are exactly CHEFORA numbers. So let us take an example where n is equal to say 5323. So this is our n. Now let us calculate the value of that expression we were given. So I is equal to 0 to d minus 1 and ni into 10 to the power I. And remember that we have to take ni from the left. So the first digit is 5. So this will be 5 into 10 to the power 0 plus this will be 3 into 10 to the power 1. Next it will be 2 into 10 to the power 2, and lastly it will be 3 into 10 to the power 3. So the number will be naturally 3235. If you see, this expression always gives us the exact opposite of our original number, right? Now the thing about CHEFORA numbers is that those numbers which satisfy this equation are called CHEFORA numbers. So what does this mean? This means that say we have a number, so the number should be equal to reverse of that number, right? So such a number, as you all know, it is called a palindromic number. So all palindromic numbers, palindrome number. So all palindromic numbers are CHEFORA numbers. So now let us just quickly list the first few palindromic numbers. So they are naturally 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we have been told that a CHEFORA number should have odd number of digits, right? So the next palindromic number, it will be 101. The next it will be 111 and so on. Now let us exactly see how we can calculate these palindromic numbers one by one. So first let us see how we can, so these are the basic numbers that we have from 1 to 9. How can we calculate 101? Well, it is not that hard. Let us see that what is the next number after 9? So it is 10, right? What we can do is we can keep the rightmost digit of each number the same and just replicate all the digits on its left side to the right. So we keep 0 same and we just replicate 1 on the right side. So it becomes 101, right? So same thing we can do with 11. So here we have 11. We keep 1 same. So first write 1 over here. Then we replicate 1 on both sides of it. So it just became 111. Easy. Now let us try with a bigger number. So maybe let us take the number 113. And we want to create a CHEFORA number out of this. So for creating a CHEFORA number, what we do is we keep the right digit same. So just write 3 over here, take 1 1 this side and also write 1 1 on the other side. Same way if you take some number like 2 4 3 5, same way you can do this, that write 5 over here and write 2 4 3 and then just write reverse of 2 4 3 over here. So this will become 3 4 2. So all these numbers are CHEFORA numbers. And it is pretty obvious that if you iterate from 1 to whatever value you want, you can convert each of these numbers into a valid CHEFORA number. Okay, so now let us see what the question is actually asking us. So first here, what we have been told to find out. So we have been told to find out the value of I is equal to L plus 1 to R, where so this is a product of A of L into A of I. So we have been told to find the value of this equation. So let us just try to write let us try to expand this value. So it will be A of L to the power A of L plus 1, right, into A of L to the power A of L plus 2, and so on. You will be eventually reaching A of L to the power A of R. Now, if you remember uh, the rule that we used to study in 8th standard about indices, that if the base is same, then we can just add the exponents or the exponents. So this will just become AL to the power of A of L plus 1 plus A of L plus 2 plus up to A of R. So this will be our final answer, modulo 10 to the power 9 plus 7. Now the question is, how do we create or how do we achieve such an answer within the given time complexity? So the first step here is that we will see the pseudocode of how to create pseudocode for storing CHEFORA numbers. So this is the first step in this problem, because if you don't have CHEFORA numbers, you cannot find the Lth or L plus 1 smallest CHEFORA number, right? So for storing CHEFORA numbers, and the next thing we will do, so since we have to calculate the sum from L plus 1 to R, what we can do is we can just calculate prefix sum for CHEFORA numbers. And then for L plus 1 to R sum, we can just do prefix of R minus prefix of L. So calculate prefix for CHEFORA numbers. So now let us see this step by step. So let us see how we can store CHEFORA numbers. So the first thing to do, or the first thing to notice over here, is that we need to find at least the first 10 to the power 5 CHEFORA numbers, because that is the maximum constraint that we have. So what you have to do is first just initialize a vector or a list. So vector CHEFORA, and then just iterate from all numbers from 1 to 10 to the power 5. So for I in range 1 to 10 to the power 5. So after this is done, we need to initialize two variables. So the first variable is the result, where we will convert this I into a CHEFORA number, and so result is equal to I, and the second is num. So this number we will use to extract the digits. So let us do the first thing that we do. So let us say we have some CHEFORA number with the digits x, 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 x. So what we are doing over here, we are separating this x at the side, and we are reversing this number and appending it to the right side, right? So what we are going to do over here is, first we are going to do num is equal to num by 10. So with this we have separated this digit. Next thing that we are going to do is, we are going to extract one by one the digits from the right side of num. So while num not equal to 0, what we will do is, we will just extract digits one by one. So we can extract digits by directly doing d is equal to num mod 10. So from this we will get the rightmost digit of the current number. So once we do this, so the next step is, we have to append this digit to the right side of this number, right? So just, it is very easy, just do res is equal to res into 10. So then this number will become x x x x 0, and just append this digit, so plus d. Then it will become x x x x and d, right? So I think this was pretty clear. So we will do this for all the three digits. So the number will be something like this. So this is a successfully reversed CHEFORA number, right? And once so now we have the CHEFORA number in our res. So just push the res value into this vector or a list. So just CHEFORA dot push res, right? So now if we do this for all numbers in the range 1 to 10 to the power 5, we will have all the CHEFORA numbers in increasing order. Yeah, and this algorithm gives us the CHEFORA numbers is in an increasing order, because it's kind of obvious that if the front numbers are smaller, then the last numbers will also be smaller, right? So we will always get CHEFORA numbers in increasing order. So now we have successfully stored CHEFORA numbers in a list. Now the next thing to see over here is how to calculate the prefix sum. So the prefix sum part is just normal. So first just initialize a list, or okay, don't initialize any list. So what we can do is, we can first set the value of sum is equal to 0. Then we can just iterate over CHEFORA. So for I in CHEFORA, what we can do is just have a vector of prefix, right? So for I in CHEFORA, what we can do is just say sum is equal to sum plus I, and then just push it into prefix. So prefix dot push sum. So with this, we calculate the prefix sum of all CHEFORA numbers, right? Now, the final thing that we have to do is that we have to output the answer of AL to the power AL plus 1 plus AL plus 2 up to AL plus R. So if you check, the above bracket is now nothing but A of L to the power prefix of R minus prefix of L, right? Since we have already calculated the prefix sum. So prefix of R will give the sum of all elements from 1 to R, and prefix of L will give the sum of all elements from 1 to L, right? So subtracting them will give us this range. So with this, we come to the final step of this solution, and that is now to find out the value of this modulo 10 to the power 9 plus 7. And if you know, there is a technique called modular exponentiation. So in this technique, what we can do is we can directly find out the powers, say a raised to b mod some number m. So using this technique, we will directly find the answer to this. So if you want to read more about this, I will paste a link in the maybe video description and you can read more about this. So this was overall the solution approach of the problem statement. Now let us quickly proceed to the actual C++ implementation. So starting off with the C++ implementation, so first thing that we are going to do is we are going to pre-compute the values of the CHEFORA vector, or all the we are going to store all the values of CHEFORA numbers. So let us quickly do that. So first we initialized a vector ll CHEFORA, and first thing we are going to do is that we are going to push 0 into the vector as the first element, so as to enable one based indexing, right? So now for I is equal to 1, I less than mx, I plus plus. So mx has maximum value just 10 raised to 5 plus some constant. And here, as I said in the solution, that I'm initializing two numbers, res and num, which both have the value I. Now we are dividing num by 10, and with this we achieve that the rightmost digit is eliminated from the number and the rest of the number is now ready to be reversed. So while num not equal to 0, then we have res is equal to res into 10 plus num mod 10. So the num mod 10 will give us the rightmost digit of the updated number. And then directly we will again do num mod 10. So this will reduce the again the length of the number. So I think I forgot to mention this in the solution approach, and sorry for that. So let us proceed that CHEFORA pushback res. So we are pushing the number res in the vector CHEFORA. So with this we are achieving the first 10 raised to 5 CHEFORA numbers. Cool. Next, what we'll do is we'll calculate the prefix sum for this. So I just initialized a prefix vector and I first push back 0 in the vector so as to again enable one based indexing. Next, what I did is I found out the size of the CHEFORA vector and initialized sum is equal to 0. Then I just calculated prefix sum normally, that sum plus equal to CHEFORA and prefix dot pushback sum. So this is a pretty standard way of calculating CHEFORA, of calculating prefix sums. Now coming to the input. So first I take input q, the number of queries. Then I took input l comma r, so the range between which the query is to be executed. And lastly, I have outputted power of CHEFORA of L. So this is the Lth CHEFORA number, A of L basically, comma prefix of R minus prefix of L. So this was the exponent. So what is this power function? So here I have written this power function. So it is a modular exponentiation function nonetheless. So I will paste a link in the description so that you can read more about this. So yeah, this was the solution approach and I hope you understood it. And thank you.